All right, thanks everyone. We're gonna start. Please sit down and yes, thank you. All right, thanks everyone. So welcome to this pop-up meetup brought to you by Canonical with our their little request, which is awesome. Thanks for inciting us into doing that. So thanks for coming. We're gonna have two talks. One is a workshop. So you'll have is it Mark and Marco from Canonical that are gonna give you their take on containers and the way they deploy. If I'm not mistaken, it's gonna be like Kubernetes and LXD, 60 minutes for OpenStack. And then you'll have our in-house Iret who's gonna do a workshop. So next slide is gonna, again, just as a reminder, make sure you register on that Slack website, just to make sure that you get all the instruction as the demo goes along. And yeah, that's pretty much it. So we're just gonna get things started with our friends from, yes?
Actually, I have a few updates.
Sorry? Oh, we are hiring. And who are we firing? We don't know, okay. So 1-to-1 ratio. So yes, was there anything in particular? Yeah, just go ahead.
Yeah, so this is like really the first time we're doing joint meetup with OpenStack and Kubernetes. So because we have kind of both of the worlds coming together at this meetup. Don't worry, we're not gonna do every week meetups now, but this has just happened that we had last week Kubernetes meetup and we have another Kubernetes meetup. So I think it's just getting so popular and the room is full. That's great. Some announcement, we get a heads up from CoreOS guys. There will be CoreOS Fest in Silicon Valley. I don't know if somebody's going, but we get a discount 20%. So if you are gonna be there, I think it's worth to check out. Yeah, and I don't know if anybody went to KubeCon here in Berlin. There was the guys from Ubisoft. Huh? Yeah, I went. So, and there was an announcement that we have Kubernetes 1.6 release. I don't know if anybody tried already here. Some features later on. Yeah, there's you guys. Yeah. So I just want to remind what is the cool stuff came out of 1.6. So the guys from Nuantic, the guys who is doing Pokemon Go, they were banging Kubernetes community to increase support for the for the node clusters, for the worker nodes to be running, because they're running Pokemon Go on Google Cloud, and they kind of the previous limitation was 2,000 nodes. So now Kubernetes supports up to 5,000 nodes, and this is pretty much was possible because of the improvements in etcd. So guys from CoreOS did a lot of improvements there, kind of combining etcd with the gRPC and doing a lot of fixes. So the bottleneck was really the etcd performance. So now it's like much better. I don't know if anybody running more than 1,000 nodes here, but it's still cool. Another big thing that everybody waits is RBAC. So everybody asking when is going to be multi-tenancy in Kubernetes. So this is the first kind of entry to multi-tenancy world with the RBAC, and it's like disabled, or there's a lot of issues in the beginning with 1.6, so a lot of people just disabling it, but then 1.7 is going to be by default. And what it gives you, you'll be able to, with kubectl, as a user, you will not be able to see someone's namespace and see what is, his, let's say, pods, or like you will be only, as an admin, will be able to see everything. So right now you have these type of things, and it's going to get better and better. So stay tuned for the 1.7. There was a lot of improvements in controlled scheduling. There was in the beginning, there was like basic scheduling in Kubernetes where you were not really concerned about where you're scheduling your containers. But there was a lot of interest around GPU. So there are like some servers with GPU, and you want to kind of somehow able to choose them when you starting your containers. So there was a lot of improvements been done, and not only improvements how to make it work, but also it's much easier right now, because before it was like annotation and stuff. Now they introduced a lot of new concepts like K8s. So would be nice to demo it one day, but basically the improvements was in terms of like you can now select GPU nodes when you're starting your containers, and also if you want to run specific workloads in the different nodes, you can select anti-affinity or affinity rules. So guys from OpenStack probably heard about them. um, and the dynamic storage provisioning is GA now, so that actually allows you. Who knows what is dynamic provisioning? Anybody knows? Yeah. So in Kubernetes, before you would have to ask admin to go and to go on the machine to the storage and create a volume, and then he will supposed to give you like ID of this volume, and you will put it to your manifest file, and you'll create PVC like persistent volume claim, and then it will be persistent volume will be attached because you specified this ID of the, let's say, volume. But it's very hard, right? Like you don't want to like go back and forth every time you need to get some, let's say, persistent volume. So now you just need to specify what type of storage you're using, and then with the manifest file you just say I want a 10 gig of volume, and it's going to be automatically created. So so that is one thing nice about dynamic storage provisioning. Also in 1.6 they kind of removing the storage from the Kubernetes code. It's like external now. So there's a lot of companies who have storages like NetApp, EMC. They all building plugins now, so you can actually attach your storage to Kubernetes. So like if you have a Ceph, you can attach as well now. So that's the update on 1.6. Any questions? Yeah, I would love to demo something out of it, but we don't have time today. Yeah, and there was the KubeCon this time. It was kind of very interesting because there was a lot of talks about CNCF. So if you know, Kubernetes is part of Cloud Native Computing Foundation, and there was some projects that also part of Cloud Native. Some of them we're going to discuss today, actually. So there is a project called FluentD. That project allows you to collect logs from containers and send them to, for example, to Elasticsearch or to some other place. There's open tracing to collect traces from containers. Prometheus allows to do the monitoring and alerting for containers and also for the virtual machines. I think there was another slide, but there was a bunch of new projects actually that joined to CNCF that we can discuss next time, like gRPC, Containerd, Rocket, and I think something else, but I don't remember now. Yeah, so if anybody is going to be participating in the workshop, you need to join this channel. So if you have any problems, you can ask me or Per to have support. We can help you out. Oh yeah, that was a slide about. Yeah, so the project that has been added to Cloud Native Foundation is Core DNS, that is going to replace kubedns in the future for Kubernetes. And Linkerd, this is a project if you want to create like a service mesh, if you have like multi-service application that needs to communicate to each other. And I already mentioned gRPC. This is something Helm using that we're going to cover today. And those two, Containerd and Rocket D, it's a new runtimes that CoreOS donated to CNCF, and Containerd is from Docker. Yeah, so I will actually forgot to put swag, but we're gonna put swag in the break. You can take stickers for Kubernetes. Do you know these guys, Deis? No? Yeah, Microsoft just acquired them, so. Yeah, so that's it from my side. I will pass to Canonical, and we'll give, yeah.
When are we getting proper support for IPv6 in Kubernetes according to you?
There was a conversation started already. The question here is where you need IPv6, like, because when you're creating your pods, or like you usually need to specify domain for pods and for services. This is internal IPs. You don't really care about IPv6. So, and which level you need IPv6?
All level, including the full interface for containers, stuff like that.
Yeah, so.
Remember, 5G field trials will start within the next 12 months. It's strictly an IPv6 infrastructure targeting IoT, and Kubernetes is not there yet. So.
Yeah, well, I think the Kubernetes project compared to OpenStack that actually implemented IPv6, but nobody's using it, they kind of think putting the priorities like this is something already has been discussed, and this is a plan to be addressed at some point, but not in very close future. But the discussion has been started. So I can actually double check and find out when they're gonna start working on it. But this, that's what I'm thinking, maybe for that part, but like internally in Kubernetes cluster, you can specify like /24 or like internal pods for the pods or for services. You don't really need a lot, you know, you just specify whatever range you need because it's internal IP range. You don't really care how many, I don't know. Okay, Mark, you ready? You can.
I'm ready. Do I need to switch this on? Or use that one?
No, you can use this one. Just give me a second. Yeah, just little thing before Mark starts. I just wanted to, because I said that this was started by Canonical, but also thanks Canonical for the food and drinks. They're our sponsor for the meetup, so thank you guys. And Mark, when you're ready.
I'm ready. So good evening. Good evening, Montreal. Thank you for inviting us to participate in this meetup and bring it all together. And thank you to Arturo, wherever Arturo is, for making a lot of the Canonical crew come down today and hang out with cool people doing cool things. So my name's Mark Baker. I'm part of the product team at Canonical. For those who don't know, everyone know Canonical? Anyone not? Canonical's a company behind Ubuntu. Everyone knows Ubuntu, hopefully. So we're the company behind Ubuntu, and there's, by coincidence, a number of us in town this week doing various things. So just a little about us. Ubuntu's been going over 12 years now, 13 years, something like that. Lots of people around the world. Most of us work remote. The reason we're in Montreal this week, actually, is because so many of us work remote. About 80% of the company works from a remote office. We get together at the beginning of every cycle. So those of you who keep up with the Ubuntu releases know that we put out Zagity a couple of weeks ago. What? Zesty. Where did I get Zagity from? It didn't sound right when I said it. Zesty. Zesty. See, we'll cut that from the tape. Zesty from... See, I was trying to be cool. I should have just said 1704. But we put out 1704 a couple of weeks ago. And at the beginning of the cycle now, so for 1710, we all get together and kind of plan what's going to go into the roadmap and customer feedback and all of those things. And so actually it just so happens that we're doing that in Montreal this week. So I put today only, it's actually this week only. So a group of us here. If you're from Canonical, put your hand up. So if you have any Ubuntu or OpenStack or Kubernetes questions, ask these people and they will help you, right? Or point you at somebody who can. What do we do? Well, with Ubuntu, we cover a lot of different things. So Ubuntu running on public cloud, so it was interesting to see Heroku there. Heroku runs lots of Ubuntu. In fact, is almost exclusively Ubuntu underneath that. It's one of our big customers. So even though you may not know it, by using that Slack channel on Heroku, you're using Ubuntu. So everything from that and Instagram and all your favorite kind of big .com tech names are using Ubuntu in one form or another. Lots of big telco companies, people like Deutsche Telekom, using OpenStack in anger with IPv6 all through the stack, apart from one little bit, which we can talk about if you're interested, but not Kubernetes just yet. And lots of other big telcos and other companies that are using it. And then on the edge of network. So anybody got a drone, for example? No one's cool enough to have a drone? A different example, but most kind of edge of network devices, whether it's routers in your home, drones, robots, those kind of things are running some version of Ubuntu. And so we're covering quite a different span. The nice thing is that these things all join up together. So whichever kind of analyst report you read, you'll see how IoT devices generating tons of data that's going across telco networks that's then being analyzed and used in whatever it is, machine-based learning type applications or different things in cloud, right? And Ubuntu is common across all of those places. So containers and OpenStack really is what we're going to be talking about. It's myself, and then one of my colleagues will come in and Marco Ceppi, who's our Kubernetes guy will come in and talk a little about what we're doing on there. It's going to be quite demo heavy, and like all demos, it will probably go wrong at some point. So we look forward to your applause at that point. But let's talk a little about containers. And so one of the things that we try and do is level set on what containers are, or what their different types of containers do. And the best way to give this example is if you look at a typical Linux machine, a physical server, it has a certain amount of storage, a host Linux file system. It will have a number of processes identified by these little black lines here. And this little dot representing an IP address or a network connection, right? Everybody knows this, everybody loves this. It's, if you're running Linux on your laptop, for example, if you drop into a shell, take a look at the file system, you'll see it, you'll see a run PS, you'll see a ton of different processes, whatever, syslog and cron and all those various different things that you know and may hopefully love. That's, you know, what we would class as a bare metal server. If we take a single process on that, and let's just call it a web process, single web process, we know where it is. It runs alongside all of those other pieces. If we see a virtual machine, looks very much like a physical machine. It is by its very nature, of course, virtual, and it runs on a hypervisor. There are different types of hypervisor, which I won't go into, I'm sure you know, but it has very much the same characteristics. So it has its own host Linux file system, it has its own IP address, it runs a bunch of those different processes. So you SSH into a VM, run PS, you'll see the same sets of processes as if you're running on a physical server. And if we had our own web-based process, that would appear in exactly the same way. If we talk about Docker containers, right? The cool kid of the container world, we refer to as being a process container. So a Docker container, which obviously you build using your manifest and other things. Yes, it will have a file system, but each container generally will contain a very small number or even only one process that's running. Right? And if you're building 12-factor apps and managing these in Kubernetes, this is very much the mantra, right? Split everything down, you get that modularity that's just going to give you the flexibility you want in highly scalable architectures. Docker's not the only game in town. There are others that do that. Each one of those process containers has its own IP address as represented here. And then there's another type, a machine container. So if you want a container type of technology, it's not running with a hypervisor, but that looks very much like a traditional machine, a virtual machine, or even indeed a physical machine, you can run a Linux container. And so for those of you who've been around the block a little while, will know containers are not necessarily a new thing. They were in Solaris back in early 2000s, called Solaris Zones, and possibly even before that. And so those things sort of build upon a true-rooted environment, very much like a machine container. And so whilst I know Kubernetes is dealing with process containers, Docker containers typically, the intersection of OpenStack, Kubernetes, and container technologies does involve a lot of what we class as LXD, a machine container. And during the demo and presentation, I will, a little further on in the presentation, we'll talk about those. Those, in the machine container world, you see, yes, the same sets of processes. So if I'll drop into a shell in a minute and show you, same sets of processes that you'll see running. And of course, your web app process to try and stretch this example a little too far, perhaps. So, and of course, we can run very many of those on a machine. So unlike VMs, where typically you'll run somewhere between 15 to 25 VMs on a physical machine, there's, I won't say no limit, because that's just a dumb thing to say, but you can run very many different machine containers on a single physical machine in the same way that you can Docker containers, right? Run very many of them, order of magnitude more. So, and the last thing actually is an application container. So in the Ubuntu world and now in CentOS and other operating systems, you have this concept of a snap, which is using some container primitives that exist within the kernel. It's a packaging of an application or a single process, but with all the dependencies that revolve around this. And this is a kind of evolving as if you like, an alternative to a traditional Linux package, whether it's an RPM or a deb. It removes a lot of those dependency problems that you may have seen, Python dependencies and others in the OpenStack world, and gives you a high degree of isolation and management. But we won't go into any more detail on that. So we talk a little bit about machine containers with LXD. We've been running these machine containers underneath our OpenStack for about 5 years now. And so we get asked quite a lot, do you see containers in production yet? All of those names that we had before, I won't scroll back because I'll have to go back through the builds, but people like Sky in the UK that are running production TV services are running those on top of containers and have been for a couple of years. Right? People like Deutsche Telekom running the core of their network are doing so on containers and have been for a couple of years. And so containers are very much in production. And one of the reasons that we can see these machine containers in production is because they look and behave just like a VM. And of course, VMs have been in production for a long time. The main difference is, of course, we get much better density without the overhead of a hypervisor. We get better performance. Your mileage may vary. Of course, we pick the best numbers when we're showing these examples, but for different types of workload, up to 20% better performance. We also get a lot of the benefits you'd see with a traditional VM, like snapshot restore and live migrations. And so this is why we've been packaging OpenStack services in machine containers for a while. Not just us, others, Rackspace, Mirantis were doing so for a while as well. And so as a very good stepping stone, if you like, for applications that are running very well in a VM, but you want to get those benefits of performance and density, drop them into a machine container, and you don't have to worry about, you know, the whole 12-factorness and putting things in processes and joining up all of those multiple different process containers. Let's look, if we look a little further into where Kubernetes and OpenStack intersect. So who uses OpenStack here? Who's an OpenStack person, apart from canonical folk? Wow. This is a great opportunity for OpenStack in Montreal and seeing as Greenfield. So OpenStack is a set of many different services that provide different capabilities or different technologies, if you like, infrastructure services for you to be able to run machines. And those are, this is just a small set or a small example of these, but things like Glance is an image repository, so when you want to launch images, whether it's Ubuntu or CentOS or something else, Windows even, that's where they get served from. Swift is object storage, and Cinder is block level storage. Neutron is a networking environment that sits around it. Telemetry is metering and data about how the environment's being used. Keystone is authentication. Horizon is a dashboard. And there are many more of these. In our OpenStack distribution, we are typically at about 15 or 16 different components that we build together, put together to create an infrastructure as a service platform. The good news is that all of those things, actually not all of them, again, never say all or everything in presentations, especially when they're being recorded. Most of those are packaged inside containers. So when we are deploying OpenStack services onto physical metal, and anything from a small number of servers, sort of 5 or 6 physical servers, to hundreds of them, we place them inside machine containers. And we do that for flexibility. Because if you want to move a service, expand a service, move services around for maintenance and downtime and those things, it's much, much easier if they're wrapped in a container than if they're just running natively on the bare metal. Right? And if we want to do things like converge services, so put many of those services on a single machine, just in testing, and then scale it out, again, it's much easier when they are in containers. And so that's exactly why we do that. Containers are running most of the control plane for an OpenStack installation if it's from Canonical based on Ubuntu. We also have them running in, I guess, what we class as user space. So many of the applications that people want to run in an OpenStack environment, they will run in Kubernetes, right? So we're working with a lot of customers today that are deploying Kubernetes on bare metal, yes, inside VMware VMs, yes, inside Amazon, Google, Azure, yes, and inside OpenStack, yes. Right? And so that's one of the great things about Kubernetes, and some of the tooling that we'll show you is that it allows you to be able to have the same application architected in the same way, but put it on multiple different deployment platforms. Right? We also see machine containers running inside OpenStack. So in the same way you can run a KVM-based VM inside OpenStack, you can run a full machine container. And that's thanks to a bit of work, actually, that one of our teams stood at the back there has helped manage and drive in, was something called NovalXD as a hypervisor inside OpenStack. So if you want to be able to run containerized application high density, high performance, bare metal level performance, you can do that in conjunction with a machine container in exactly the same way that you would with KVM. Demo time. Just in the nick of time as well, because everyone's starting to fall asleep. So what I wanted to show you was, I didn't realize actually that the second session was going to be a workshop. So otherwise I probably would have been a bit more adventurous. But if you have an EC2 account, you can play along. Or if you have a machine running Ubuntu with about 16 gig of RAM, you can also play along, which is probably not many of you in the room. But so what I wanted to show you was essentially how you can install OpenStack in conjunction with containers, right? I know in the title we said 60 minutes, right? Maybe. We'll see. So who has an EC2 account? Who doesn't have an EC2 account, right? Everyone has an EC2 account. So this is my Amazon EC2 account. You'll see various different things I've been playing with, none of which are working, but you'll running right now. But you will see at the bottom an instance that I launched at about an hour ago, I think it was. So this is running, and you can see the IP address here. And if I flip over to my terminal, you'll see if I exit out and do the same thing, it's running on the same IP address. Hopefully you can see that down there. So it's a real live instance running on EC2. And I may have to... You still see that? Yep. So on this machine, I have a single container running, right? It's a single machine container, and that's running. It's a little environment. It's something called a controller node. And that is something that I've put on just previously in preparation, just because it speeds up the demo. And that's there after I have run something called conjure-up, right? So if you go to this website, again, you can play along if you want in real time, conjure-up.io. ConjureUp is a means by which we can deploy quite complex applications, OpenStack in this case, and then you'll see in a little while Kubernetes as well. Complex applications inside containers across multiple machines, or in this case, on a single machine. So you can get going with that using sudo snap install conjureup-classic. And if I go through my history, you'll see all my typos now, but if I go through my history in there, you will see at some point there is the ConjureUp. Is it? There we go. There you see ConjureUp is the, and sudo snap install. There we go. You'll see that. So that was all I did in prep just an hour or so ago before we came down here. And so if you go and launch one of these instances on Amazon, ideally you get somebody else to pay the bill, as an M4 2X large isn't that cheap. But, and remember to turn it off afterwards, but go and launch one of those on Amazon and essentially run that history. Sudo snap install conjureup-classic, and then you just run this command called conjureup, and that's exactly what we're going to do right now. So conjureup, as I say, is a means by which it allows us to be able to deploy applications in containers, right? Say in this case in a single machine, but also if you wanted to across multiple machines. So, and for the sake of this, I'm going to do OpenStack in Novel XD. So if we go ahead and hit there, you see I've already got this controller environment. It needs a controller environment, which is basically the worker that manages the containers and spawns those containers and loads processes or services into them, right? And this is why I was cheating to try and do it in 60 minutes, right? If you do this, it should finish a bit quicker. If you run this yourself first time, it'll actually just have that single option of localhost above it first, and then you'll click that, and then it will create this controller environment to begin with. And that process takes about somewhere 15 to 20 minutes, depending on your environment. On my laptop, it takes a lot longer than it does on an M4X large, right? So if we go ahead and choose that, now it's asking me about all these different OpenStack services. And so because of the screen, if I go out a bit, you'll see the actual service names themselves. And there's quite a few of these. So it's lots of things that you will know and maybe love, RabbitMQ and MySQL and infrastructure services that go to make up OpenStack. Things that you may not be familiar with if you're not an OpenStack person. So Nova Compute and Glance and Keystone and those other services. Right? The good thing is that if you're just getting started, you don't really need to worry about them too much right now. So what we can do is, if we wanted to, we could go ahead and configure some of these. So if I wanted to configure the number of units or change the password for the authentication, those things, I can go ahead and configure those. But I'm not going to do that. I'm just going to let it run, and you'll see other bits and pieces that I could go and change. So if I wanted to go and change the architecture, I could allocate how many cores and how much memory I want to allocate to these things, right? Because I'm only running on a single machine, I'm just going to leave it all as it is for the purposes of demo. Don't deviate from the path too much when doing a live demo. It's generally good advice. So I'm just going to leave those things as they are. But if you want to play around with them and try them out, if you've got a nice big beefy machine and you want to partition it up, allocate things, you can certainly do that. So I'll go ahead and apply that, and I'll choose the just do it all for me option at the bottom. This one, which is deploy all the remaining services with their defaults. And I'll go ahead and do that. And it starts deploying containers. So if I go ahead and you know, it's always impossible to type when you have a room of people watching you. If I go ahead and just go and see in that environment, and then at shift V, that should do it. Oh, thank you. That should do it. So this is the same machine, obviously, and if I do LXC, that's list, give me a list of all the containers that are running on that machine. You'll see these starting up. So there's more and more of them starting up as we go, and you'll see that is going to be referenced. Oh, it's going to be in here. So we are spawning a number of these containers on this single machine and starting to install or develop services into them. Now this is going to take anywhere between half an hour and 40 minutes. So I'm going to, at this point, drop back to the presentation and introduce my colleague here, Marco Ceppi, who's going to talk to you about Kubernetes. And if I'm not mistaken, it's probably going to be Kubernetes 1.6.
It's absolutely Kubernetes 1.6.
Good, good, good. So let me give you the dongle and step out of your way. But we will come back when Marco's done and see whether that's completed. And so you can see if it was really real or not.
All right. Do I need to project or anything, or? Oh, it's not detecting my displays. I can try with the new display port. There we go. I'm not gonna. I guess that's all right, actually. I'll leave it alone. All right, thank you. Cool. So I want to talk about Kubernetes. I'm just curious. I know polls have gone over pretty well so far today, but I might as well ask anyways. How many people here are actually running Kubernetes? Cool. How many people are trying to run Kubernetes? How many people are regretting running Kubernetes? It's okay. It's not easy. Operating software in general is not easy. It's especially software today. I mean, we just saw OpenStack, and it's 23,000 components to install and configure just to get this idea of OpenStack running. Kubernetes, thankfully, is slightly simpler in architecture, but it's still complicated. It's etcd. You have to have SSL certificates. You have to have a master API server, kubelets, Docker, maybe Rocket. Are you running Calico? Do you have Flannel? All of these things come together, mixed up, and then hopefully you have something running that developers or you can use, and it doesn't break. And if it does, good gracious, good luck debugging Golang code. So I want to show you guys just a couple of interesting things that we've been doing. So we saw Conjure-Up. You understand what Conjure-Up does. And the idea behind Conjure-Up is let's just make it really easy to get it so that you can deploy something. And to be honest, there's a lot of projects today that make it really easy to deploy Kubernetes. I mean, Minikube makes it really easy on your Mac. If you're running in a cloud, there's a bunch of push button options. You get Kubernetes running. What really becomes interesting and what Conjure-Up gives people that is kind of the next problem with Kubernetes is what do I do after I deploy it? What happens after the next day? What happens when I need to scale it? What happens when I need to upgrade it? What happens when I need to operate it? What happens when it becomes software that becomes my daily burden? When my alarms are going off constantly because something's breaking, etcd's filled up to the rim, or Raft has decided to go re-elect everything every 5 seconds. These are the kind of problems that we're really interested in figuring out solving, is what makes it so that we can make operating software not suck, or at least suck a lot less. So we could do a conjure up, but I've already went ahead and conjured up something. So I'm going to go ahead and conjure up this because it's a lot. Oh man, this is going to be, let's see how this works. Conjure up's going to complain about my window being too tiny. So I'm just going to go ahead and conjure up a Kubernetes core. So what's Kubernetes core? For those of you who are familiar, it's pretty straightforward. Let me just choose this controller here. It's a master, that's your API server, your schedule manager, your controller manager. And it's a worker, that's kubelet, kubeproxy, Docker. And then it's etcd and EasyRSA. We use EasyRSA to provide TLS certificates. It's your private key infrastructure. You can swap these things out with other components, but this makes it the most portable solution. So whether you're deploying it on a public cloud, where you maybe have access to get Let's Encrypt certs, you can do that instead. If you're deploying it on bare metal, on premise, in your VMware cluster, on top of your existing OpenStack or on bare metal, and you have super crazy firewall rules where you just can't go grab certificates from some random endpoint, this makes it really easy to deploy it there. So I'm going to go ahead and just say, yeah, deploy this. And this is the same thing we saw before. Machines will start popping up, and Conjure Up will go do something. So this is deploying this on Amazon. I could have chosen various other places to do this, including on local machines, LexD and such. But what I want to show you is what it's like to operate. What happens after Conjure Up is done? You have a Kubernetes cluster, and that's great. What it's like to operate. So I want to show you what that looks like a little bit. And how we operate Kubernetes and how we've gone to build what we call a distribution of Kubernetes, the canonical distribution of Kubernetes. But really what it is upstream Kubernetes in a way that makes it easier to manage, operate, and just suck less in general from your day-to-day life. So I'm going to query a status of my cluster, and I see, I'm on the wrong cluster. Let me look at all the cool little models I have here. I want to use the one called K8s. So I'm just going to export model equals K8s. Much better. So I have here a deployed Kubernetes cluster. I deployed it about 10 minutes ago while Mark started talking. I realized I should probably have a cool demo to show everyone. And if you notice, here's a couple things. So I'm using etcd 2.3.8. I'm using Flannel 0.7.0. And I'm using Kubernetes 1.5.5. And that's the last major release of Kubernetes up until the end of March. And so right now it's, well, honestly, it's woefully outdated. I think 1.6.2 is the latest release, and 1.6.3 I'm sure is already baking in the oven. And soon enough we'll be at 1.7, and 3 months later we'll be at 1.8, and 3 more months later we'll be at 1.9, and hopefully eventually we'll hit a 2.0, and maybe things will slow down, and maybe they won't. But to keep up with this release cycle, you got to keep upgrading. And to keep upgrading, it's not necessarily the most straightforward of bits. There's potential downtime can occur. If you're upgrading kubelet, that means you have to restart it, which means, well, your workload's just rebooted. That's okay if they're stateless, but if they're stateful workloads, if the things that you just don't have the available resources to reschedule, you've suddenly lost and had downtime in your application. That always isn't the most pleasant thing. So I want to show what upgrading a Kubernetes looks like. I'm going to copy down a config file so I can actually access it. So let's just do a kubectl cluster. Oh, sorry, I'm going to call it kubectl. I found out, people tell me it's not cute, you shouldn't call it ctl, it's kubecontrol, but that looks like ctl to me. You guys can't see, oh, you can see that, perfect. So I've got a cluster running, this is on Amazon, you could go hit it, but you don't have access to access it because you don't have my cool X509 certs for my user. I'm just going to do a watch. So I've got 2 nodes. I've got 2 kubelets running. They're version 1.5.5. They were launched 20 minutes ago and 41 minutes ago. I'm going to split my screen. I'm going to watch this Juju status. So what Juju status is telling me, it's like a live snapshot of my of my cluster. Wrong cluster. That's the one that we're just turning up over here. We can kind of see it's progressing. I want to go back to this model. Okay, so we have a 151 cluster. It's deployed against just 3 machines in Amazon. So if you notice real quickly down here at the machines, at the bottom level here, we see that we have machine 0, 1, and 2. Those are Amazon instance IDs, that full 32-bit instance ID. And we see those map up on the columns here. I'm going mobile. Going rogue. I'm not going that rogue. Just rogue enough. Just rogue enough. So, machine mappings here. So I see etcd is on its own machine. I see masters on its own machine. I see workers on 1 and 2. And then easy RSAs and LexD. So what we've done is we've actually modeled a little bit more density. I've got 5 components deployed across just 3 machines. And I'm using things like LexD to model density and isolation. So EasyRSA thinks it has its own machine, its own init process. It's got its own root disk. It has apt update. It's got root. It's got cron. It's got all these things. But it's just another LexD machine running on top of an Amazon instance, much like what Mark was doing earlier when he comes back and shows us there. So back to unroguing. I'm going to go ahead and upgrade this cluster to 1.6, whatever the latest, I don't know, 1.6, whatever it is. I'm just going to go ahead and upgrade it. So let's do that. Juju config for Kubernetes master, and I want to set the channel for Kubernetes to be 1.6, and I want to use the stable release for 1.6. I can make this /candidate, so I can get whatever candidate releases they're baking. I can make this /beta, so that'll get you any alphas or betas or devs that are available. Or I can do /edge, which is like the bleeding edge master trunk daily builds. I'm not that crazy, and this is a cluster I want to keep running, so I'll use the stable channel. And what you'll notice is Juju starts taking care of that for me. So what's happening in the background is these things here, these components, these applications that are deployed, are backed by this construct called a charm. A charm is basically a bunch of operational code. And it's not a lot, but it's basically a couple hundred lines of Python or Bash that handles an event engine. The operator wants me to go do something like configure a cluster. You know what? You know what I did wrong? I didn't export my model. I just did that against the other model. Doesn't matter. I don't care about that one. We can always redeploy it. Let's do that again. That's not what I wanted either. One more time. All right. So what's happening now is these apps have a little bit of code backing it. They're running there on the machine. And what this is doing, it's helping doing not just deployment and installation, but also managing lifecycle events. Like I want to go ahead and just live reconfigure my cluster to a new version of Kubernetes. And you see it's doing that now. It's installing a bunch of new stuff, a new API server, a new controller manager, a new scheduler, any other bits it needs to update and execute. And what will happen is this will eventually switch the master from 1.5.5 to 1.6, whatever the latest stable is. I don't even remember right now. I think it's 1 or 2. And we'll see that reflected in the app in a few minutes. And what will happen is this will do it in a way that is repeatable, reliable, and is something we can re-execute. It's item potent. We can keep making these configuration changes, and the operational code will know how to handle those things. And we do that by exposing this as a level of operations you can actually perform. So if you look at the actual configuration for Kubernetes master, and we pipe that to less, we see all things operators love to see, YAML. And we see things like being able to switch allowed privileged modes on and off. We see the ability to do things like changing the actual channel of the Kubernetes you want to install, DNS domains you want to map to, whether or not you want to add on dashboards and such. If you're using things like Nagios, the context for it. And all these things map to configuration that's a very explicit interface for modifying these things. What makes it so that I don't have to SSH into a machine and create something that's a morph from the previous state. The whole point of these things is to stop operators from having to go in and manage machines one at a time and manage them as you actually want to, which is a declarative version of this is what I want you to do, and then something that rectifies that. What this basically gives you is managing your infrastructure much like you would your workloads on Kubernetes. It's that idea of I declare a state I want it to be in, and it operates there. Kubernetes is the primitives to do management for Docker containers, compute, networking, and storage for a Docker-like container. What Conjure Up and Juju and Charms give you is the ability to manage that same idea at that infrastructure level. These aren't immutable machines. They aren't workloads that are running single processes. They're full-blown machines. They have a lot of complexity to them, and they need to be managed in a way that's concise. So we'll wait for this to finish. Where are you? It's doing stuff. It'll get back to it in a second. But we see that at the top, the API has never gone down. I've still been able to continuously every 2 seconds query to find what nodes I have running. And in fact, because it's a dev cluster, I'm just going to upgrade the rest of this. Because why not? I can do that. You know what? You can't see. Now you can. So I'm just going to go ahead and juju config Kubernetes worker channel equals 1.6 stable. Oh, it's way down there. Shoot, you all should have spoke up. Juju config Kubernetes worker channel equals 1.6. So I'm just doing the same thing now with the workers. And so if we watch the state here, again, we're just kind of cycling through every couple seconds. We'll see it's processing our events. And what's great about Charms is they're a feedback loop. It's not just a dumb, I'm going to do what you tell me to until I run into a wall. It's I'm going to evaluate what you're trying to do and make sure you don't do anything crazy stupid that could potentially wreck your life or your pager status. So in this case, it's stopped me. It's like, hold on. You're going to upgrade kubelet. And we all know what happens when you upgrade kubelet. It restarts your whole processes, which results in downtime for applications, or at least potential downtime for applications. So what the charm says is, I need you to really tell me you want to upgrade. Like, I know this is your intended state, and I know you're heading there. You're going to get to the 1.6 goodness, but I need you to actually run an action to say, yes, I'm ready to. And what this allows you to do is a more finer, granular set of operations against individual actual machines. Since we have 2 units, 2 physical machines backing our worker pools, 2 physical nodes up there, we want to make sure that we don't do anything crazy. So this allows us to do things like execute a series of actions, which I'm going to do right here. So if I look at these actions, these are a set of things that you normally do as an operator, but distilled in a way that's, again, that explicit interface of management. So if I do a Kubernetes worker, so these are the actions I can do. Normal kind of garbage collection stuff. Clean up all the images in the Docker, local Docker cache. That gets big after a while and can fill up disk. Get rid of any containers that are no longer running on there. But also things like pause, which is effectively a cordon on that node in Kubernetes, which means don't actually schedule any more workloads here. And then a drain, which is effectively reschedule any running workloads on another available resource. And I can use these tools in concert with upgrade to say, okay, I'm going to take these 3 nodes out of service. I'm going to go ahead and pause them. I'm going to go ahead and then upgrade them. I'm going to make sure they actually upgraded to 1.6, okay? And then I'll just resume them, make it so that I can reschedule workloads on them. And that allows me to do things like A/B. I can go ahead and cycle through the process of saying I'm going to do a chunk at a time. I can also do something crazy and just say, you know what? Dev cluster, don't care. Upgrade them all in one shot. Let it go. Let it ride. So for this, I'm going to go ahead and just say upgrade. I'm not going to worry about pausing and resuming. I'm just going to let it run. I'm going to go ahead and say juju run action on Kubernetes worker /0. So what this is I'm running this specific task on this, on this guy here that's blocked. Sorry, juju run action Kubernetes worker /0, and I'm going to run just the upgrade action. So we'll see this actually happen live in the system. So I'm going to go ahead and copy this here, which is the hash of the action I'm running. This is all asynchronously executing in the environment. Events are queuing, they're firing, a message bus is happening, code is reacting to this. If I don't watch this soon, we're going to miss it. Juju show action output for this hash. So we see it's running, and we can verify that if we poke this down a little bit. We see here that it's running that upgrade action. And we'll see in a few minutes, one of these 2 nodes will drop offline. They'll go from ready to not ready. In the meantime, because I've been impatient and didn't wait, our master finished upgrading. It's just doing the last step leg. So we see it's 1.6.1. I guess that's the latest that's out for today. And we see here, I missed it, shoot, sorry. We see here one of our workers just jumped from 1.5.5 to 1.6.1. So it completed the upgrade sequence. It's re-registered. It's been registered as healthy. Workloads will be scheduled, and the action completed. If it failed, or if there's additional output, these actions allow you to also interact again with you as the operator. It'll say, hey, this failed, and here's the reasons why. Or this succeeded, and here's the follow-up actions you need to do. So let's go ahead and just finish this off by running the upgrade for the last worker. And I'm not even going to bother with that. We'll just watch the status up here at the top. So in a few minutes up here at the top, we'll see that second one in the entry. We'll just drop offline, pop back up, 1.6.1. And then we'll have upgraded our cluster from 1.5.1, from 1.5.5 to 1.6.1. And what's great is we can repeat this step over and over again. I've deployed these 155 clusters and upgraded them hundreds of times for demos like this, actually in our production environments, in our labs. It's because we've taken the time to distill the idea of operating software, and we've treated it like, what happened? Oh, it's cool, it's not ready yet, it'll get there. Sometimes kubelets need a little bit of time, recuperate, and now it's back again, yeah. It's okay. Also, if it failed, it's a demo, remember? If it succeeded, this is production, but if it failed, it was a demo, so it's okay. That's basically it. So it's still finishing up. We see here states that master's waiting to verify everything's okay. It's going to be in that pattern for a little bit longer because, well, it was in a mixed cluster environment. It had 1.5s and 1.6s. It wasn't quite sure what things were going on. It still never dropped the API server, and I can still keep poking the API server. And in about 3 or 4 minutes time, it'll run its health checks again, and it'll see everything's good or healthy, or it won't, and it'll let me know by raising red flags or paging me or yelling at me. But that's it. That's upgrading the cluster. And what's great is upgrade's just one of the many lifecycle cluster events. How many people have had to scale their Kubernetes cluster in the last 6 months? Add more capacity. It's going to happen. These Docker containers are small, but they fill up after a while. Don't you worry. So for something like that, if you want to add more capacity or enable HA, I could just do something like, give me another unit of Kubernetes worker. Give me 5 more units of Kubernetes worker. And if we watch this status here, we'll see that Juju will go ahead and take care of allocation of those machines. It'll fetch them from Amazon, from GCE, from Azure, from, sorry, everyone in the back, but I can't make it go any further up. It'll fetch those machines, it'll provision them for me, and it'll repeat that same operational process. It'll make sure all the integrations are done so that the kubelets are attached to the masters. It'll make sure that Flannel is backed by etcd and has the right information and credentials. And it makes sure that if I were to scale etcd out, which, you know what, one etcd running is probably not a good idea. Let's go ahead and just scale that up as well. Juju, add a unit. We want 2. You want to always scale them from 1, 3, 5, and 9. That way you maintain quorum and Raft is happy. I'm going to add 2 more units of etcd. And now etcd will go and fetch 2 more additional machines, add more machines, run my bill up on Amazon. But soon I'll be able to have well, I wouldn't call it highly available, but a slightly more robust etcd cluster. And all this stuff will happen, reconfigure, and repropagate messages without having for me to intervene. This is a peer-to-peer almost orchestration network of chain of actions. So that's effectively why you would maybe want to use something like Conjure Up Kubernetes, because after that day 0 config, after that GUI goes away, after you can sit here and say, oh, it's still waiting for this to be done. But after you can say, yeah, my deployment's done and everything's running and everything's happy, it's that next step. It's the how do I tap into my monitoring? How do I scale this workload? How do I upgrade this workload? How do I reconfigure this dynamically? How do I add in more services or take things away? All of that stuff has been codified so that when you go to that next day, that next week, that next month, it actually comes out being pretty helpful for you. And all of this is open source. It's all open source. The charms, the operational knowledge here for Kubernetes all live in the upstream Kubernetes repository. And it's there that we keep track and make sure that these are moving with the project, and they're always available at the next release of Kubernetes that you can go ahead and operate and upgrade to. I think that's it for my, I don't know what time anywhere. You wanna show OpenStack? Let's do it. Yeah, I know, I feel it's coming soon.
Anyone, any questions for Marco whilst I'm plugging in?
Yeah, I'm curious. How's people's experience with Kubernetes so far? Where are people running them? Are they dev production clusters, or everyone having a good time? It's a cool project and it's a lot of fun, I will admit. It just comes with dragons, but so does every large-scale software project. All right, cool.
Cool. So this was the screen that we left before. This was our install process that was running previously. You'll see we go over here and over here. Not that one. Not that one. There we go. Okay. I was looking at the screen because we've been checking on progress at the back. It's gone now. But this is a screen that we left before that was running that install process. Now it's basically 95% of the way there. It's asking, do we want to import images into our running OpenStack? So we've got basically the ability to launch VMs in that environment. So we'll say, yes, we want to import some images. Do we want SSH keys? Yes, we do want to have import an SSH key, so we'll import that. Do we want to configure networking? It'll do that in a second. This actually has to complete the previous two before we do that. Whilst it's doing that, these are two slides that Marco didn't use. There we go. Read those in your own time. But I will give you the, there we go. So next steps, if you want to give this a go yourself, and we really encourage you to do so, you can get access to an Ubuntu 16.04 instance. Now you can do that on your laptop, you can do it in a VM, you can do it in EC2 or your favorite public cloud, I should say. If you want to install OpenStack, you're going to need a fairly big VM, so at least 16 gig of RAM. The more the better, more cores the better, because you're running a great many different services. Install Conjure Up and off you go. Conjure Up Kubernetes or Conjure Up OpenStack will give you the same result. How much memory would you need for kubes?
If you do just two machine Kubernetes on your laptop, it's just like 4 gigs of RAM.
Okay.
As long as you don't load up with Docker containers, it's pretty idle.
So it's the easiest way to get Kubernetes up and running on a machine today, we think. So and we'd certainly value your feedback and see whether you agree with that or not. So please, I guess if this was being recorded, you'll be able to see this again in real time, but sorry, at a later date. If you want to, we flip back. Hopefully I've given it just enough time to do this. Anybody, any questions? This is the final bit. The last 100 yards. The vinegar strokes, as we'd say in the UK. What's going on with Ubuntu Snappy? Anybody in the audience want to answer that?
Yeah. What do you want to know about it? What?
What's going on?
So, what you saw today, a lot of this was actually powered by Snappy under the covers. We use Snappy to deliver Kubernetes binaries on disk. It gives us a really secure way to isolate and secure and confine those binaries. It also gives us a really good way to do transactional updates. So it's an Ubuntu machine. You can SSH to it, you can poke around, you can have to update it. But when it comes to snaps, those binaries can't be touched. They're read-only blobs, which make it so that we know it's secure, we know it's the same binaries that were signed from upstream. And when it comes to upgrading, if an upgrade fails for whatever reason, Snappy will roll it back to the last version. So it really makes sure that it does it takes a lot of the burden of having to do that for yourself automatically, oh crap, back it up from the last version kind of a thing. Snaps are used in quite a lot of different software projects. Ubuntu Core, which is that whole read-only small IoT thing. Lots of interesting projects. Drones were mentioned, use Ubuntu Core a lot for that, which is a really small, transactionally updated operating system for the entire bit. And it's used quite frequently there on those edge devices, those things that swirl away, cameras like the one recording us, maybe not that one, but similar ideas to there. Things you set and forget that are coming in thousands. So yeah, it's really cool. If you've never built a snap before, it's really easy. I've bemoaned it because I've been doing Debian packaging for such a long time, but it actually was really nice. Just a couple of lines of YAML, and then you run a command, and boom, you've got compiled binaries securely delivered. Cool question. I'd definitely check it out if you guys haven't.
So just to make the point here, as you may have noticed on the screen, this completed. It's created, gave us the URL here to access the OpenStack dashboard. I haven't logged in yet. The username and password was there as well. So we go and click connect and cross the fingers. It should see a fully working OpenStack dashboard. And then we try again.
Did you type OpenStack right?
That's the problem. I'll try it again. And we'll bail right there. I'm not quite sure what it will be. No, it's clearly not working. So we'll have to debug that, but never mind, at a later date. But you will see that it's a demo. It's
Horizon's definitely running though.
That much it is. So, all right, not to worry. We'll bail there, but it's definitely Horizon's OpenStack's all installed. We'll have all of those containers up and running. It's a shame that that didn't quite figure out at the end, but we'll be around for the next hour or so during the workshop or whatever. So please do, if you want to come and talk to us and find out a bit more about how you can try Kubernetes with Ubuntu or even OpenStack, we'd welcome your questions. Thank you.
All right, thank you. I think we can take a small break since you ate all the pizza and drank all the beer. So I think you need a bio break. So let's take a few minutes so that Ira can set up, and then we'll continue. Thanks.
Mike, I can use that one, right?
For you sticker fans, there's a bunch of stickers here at the bar, so go nuts.
So we already posted the first part of the workshop to the Slack channel. If you're not already registered, you can go ahead and fetch it there. So yeah, guys, can you please raise the hands who is going to do workshop? So we're going to give the virtual machines for you. So 1, 2, 3, 4. That's a really small workshop. Hey, how are you, man? Did you guys registered? We registered. So you wanna come? So it seems we cannot go too far because it's already 8 o'clock, right? So I don't want to do it like till 10 o'clock. So we're gonna cut some corners, which is fine, but I don't want to cut corners on you. So as soon as they will, because the first part is really for people to make sure that we set up. It's not important. Second part is more important that you presenting and also my part. So I'm just really uncomfortable.